Hello, in this video I will be doing a deep dive into the graphing application on the TI-Nspire technology. Let's get started by choosing number 1, New, and choose number 2, Add Graphs. This is your graphing window, and at the very top you will see your entry line. Let's actually begin by going to Menu and selecting number 9, Settings. You are now in your Graphs and Geometry settings. Here is where you can change the settings for any graphs or geometry application. Use the Tab key to go between the options. The first thing I wish to point out is the Grid feature. For the TI-Nspire CX 2 series, you have the ability to select lined grid so that every graphs page will have a lined grid each time you open a graphs application. If you have a TI-Nspire CX, you will have to turn on the lined grid feature each time you open up a graph application. Continue pressing the Tab key to scroll down and see additional features. I strongly encourage having the automatically find points of interest checked. To check or uncheck a box, use the click button in the center of the touchpad. Do not press enter, as enter will automatically select the OK option. I'd also recommend selecting the automatically label points feature. Tab on down and select OK. Your entry line is at the top of the screen. However, sometimes it might vanish to show you more of the graph. If you were to press Escape right now, the entry line vanishes. To get it back, you could press the Tab key, or you can press Control followed by the letter G, and that will also hide or show the entry line. Tab or Control G will always get your entry line back. Let's graph a linear function. We'll start with 2x plus 1. When we press enter, we will see the graph of f1 of x equals 2x plus 1. We could press the Tab key to get our entry line back. Notice it defaults to f2 of x. We can press the up arrow on the touchpad to see f1 of x. Press Escape to exit the entry line. A different way of editing f1 of x is to move your cursor on top of f1 of x. It will say Label and then double click. This way it goes directly to f1 of x for editing. I will press Escape to get back to the full screen. Using my touchpad, I can move my mouse around the screen. Depending on what it's hovering, the cursor will change. Because I have a linear function, I will see either 2 circular arrows or a 4-directional arrow when I hover the graph. The 2 circular arrows appear when I'm hovering the end behavior of the linear function, and the 4-directional arrow appears when I'm on the center of the function as it appears on the screen. If I have the 4-directional arrow and press Control followed by the center click button, that will grab my graph. The slope remains the same, but the y-intercept changes as I swipe my finger on the touchpad. This is great for talking about parallel lines. If I wish to change this back to its original function, you can press Control, Escape to put it back. If I use the 2 circular arrows and press Control followed by the center click button. The y-intercept will remain the same, but this time the slope will change. To let go, I can simply press Escape. To put it back the way it was, press Control Escape. If I wish to change this function, I will move my cursor on top of it where it says Label, double click. That'll open up my entry line in f1 of x. I'll use my delete key, and I'll replace my linear function with a quadratic, x squared. When I press Enter, f1 of x is now x squared. As I use my cursor now to hover the function, I get a new icon. If I trace with my cursor, I see the familiar 4-directional arrow as I'm near the turning point. As I move along, I see the new icon. This new icon allows us to change the stretch factor. Press Control followed by the center click button, and as you swipe your finger, you'll see the lead coefficient in front of x squared now changes. As that number gets smaller, it starts to widen. You can explore concave up and concave down. Again, to put it back the way it originally was, Control Escape to undo. With the 4-directional arrow, Control click to grab, and as you move that turning point, you see our function now in Vertex Form. Put it back the way it was by pressing Control followed by Escape. Let's now press the menu button and let's explore number 1, Actions. In the Actions menu, I'd like to point out number 4, Attributes. The Attributes icon is in the upper left-hand corner. We could now hover our graph of F1, click on it, and we can now change the attributes of our function. We see that there are 3 options for the line weight. Right now we're on option 1. If I press the right side of the touchpad, I can see 2 out of 3 is line weight is medium, and the third one out of 3 is line weight is thick. So you can play around with the line weight, press the down arrow. There are 3 styles for the line. This one is continuous, right arrow. This line style is dotted, right arrow again. And this line style is dashed. You can cycle through and explore. Label style. The default is the 3rd out of 5. Left arrow, label style, I can change it to just F1 of X. 1 out of 5, just F1. As I right arrow, the 4th one is Y equals F1 of X. And the 5th one, very familiar for those who know the TI-84 Plus family, Y equals X squared. I'll change it back to our original. Label parameters will come up when we start to do sliders. But for now, we'll press Escape to turn off our menu and Escape again to close up our attributes. Let's go back to Menu. Select number 1, Actions, and scroll down through our options. Text is nice if you want to add labels to your graph screen. Number 8, Coordinates and Equations, will come up if we wanted to actually label some coordinates on our graph. I'll scroll down to the last item, Math Draw. Math Draw is only in the software. It is not on the handheld. If I select Math Draw, I see in the upper left-hand corner the Math Draw icon. I can now create freehand objects. Here is circle A, and I will attempt to create a rectangle. And there is rectangle B, C, D, E. I want to clean my screen up a bit. I'll select Home. I'll select number 1, New. And when it says, do I want to save? I'm going to say no. I will select number 2, Add Graphs. I'll go back to Menu, and this time I'll select number 2, View. The first section is how I can work. I can work in a graphing window, a plain geometry window, or 3D graphing. If I select number 3, 3D graphing, I'm now in a 3-dimensional window. I can put in sine x times cosine y, and when I press enter, I see a 3D graph on my handheld. I can grab and move the screen to see it from different points of view. I could press the letter A for an auto rotate, and I can see it from my different planes: the X plane, the Y plane, and the Z plane. I can grab and adjust. I can magnify my graph by hitting the multiplication symbol, and I can zoom out by hitting the division symbol. To change it back to our regular view, I'll press Menu, I'll select number 2, View, and I'll select number 1, Graphing. Let's go back to Menu, select number 2, View, and those who have a TI-Nspire CX, not the TI-Nspire CX2, option 6, Grid, and then number 3, Lined Grid, is how you can turn on your lined grid every time you open a graph application. I'll escape out of this menu, press escape once more, press escape to close your menu, and now let's look at window zoom. Let's type in x raised to the third power, right arrow to get out of the exponent, minus 7x squared plus 8. When we press enter, we get a very large graph that goes off our screen. I'm going to move my cursor on top of my label, press Control followed by the center click button to grab it, and I'm going to reposition my label out of the way. I'll press Escape to let go. Window Zoom is the 4th item on our menu. So if I press Menu and select number 4 for Window Zoom, I have my menu for changing the dimensions of the window. I will select number 1, Window Settings. This should look very familiar to anyone who has used either a TI-83 Plus or TI-84 Plus in the past. You can change your X minimum and X maximum. You can change your Y minimum and Y maximum. I'll attempt -20 for my Y minimum, and I'll put in +20 for my Y maximum, and I'll select OK. As you can see, one drawback to doing it manually is that you're guessing at where you should set your window dimensions. I'll press Control Escape to put it back the way it originally was. Let's go back to Menu, back to number 4, Window Zoom, and let's look at our other options. Zoom Box allows you to zoom in on a region that you create in a box. Zoom in zooms in. Zoom out will zoom out. Zoom Standard will get you back to your traditional window. Zoom Quadrant 1 will only focus on the first quadrant. Zoom User allows the user to set their window parameters. Zoom Trig when you're dealing with trigonometric graphs. Zoom Data when you're working with information stored in a list and spreadsheet. And Zoom Fit, very popular for problems like this where we allow the calculator to decide what is the appropriate window. However, there is more. We have Zoom Square and also Zoom Decimal. If we were to select letter A, Zoom Fit, we see the entire graph, but with a lot of extra space that is not needed. I'm going to press Control Escape to put it back the way it was. You can play around with the window zoom tools to find which of those best suits your interests. Personally, I like the fact that the Inspire allows you to grab and move. If I position my cursor in quadrant 3 where nothing's going on, and I press Control followed by the center click button, I can grab the graph paper and I can reposition the graph paper. This will allow me to manually set up my window. Control Escape puts it back the way it was. Moving my cursor to the axes, and it says axes, I can grab the tick mark and then move towards the origin for a zoom out and away from the origin for a zoom in. This allows you to, again, manually see the best window. We can now see all of the graph. There's still an issue with a lot of empty space not being used. I recommend moving your cursor on top of one of the 4 end axis values. It will say text. Double click and that will open up your field. You can then change that value. I will make this one 8. I will press Tab. Tab allows you to go clockwise around the graph screen. I'll replace this with -50. Tab. I'll change this to -8. Tab. And I will replace this with 50. When I press Enter, I now have my graph window completed. It is important to figure out which method you prefer for resizing your window. You can go through the option in the menu, Window Zoom, or you can do it manually by grabbing the screen, grabbing a tick mark, or changing the end axis values. Let's press Home, select number 1, New, and say no to do we want to save the unsaved document. Select number 2, Add Graphs. Let's now look at the Graph Entry Edit option when you go to Menu, number 3. The default is Function, so let's look at number 2, Relation. Relation graphing allows you to put in any equation in terms of x and y. So, in the past, we could never graph x equals. Now, we could do x equals 3, press Enter, and we see a vertical line at x equals 3. I'll press Tab. I'm now in relationship 2 in terms of x and y. If I'm a student who struggles to get the y by itself in a linear function, that's no longer an issue. 2y plus 3x equals 6. When I press Enter, I now see the graph of 2y plus 3x equals 6. I'm going to get rid of my two relations, Control Escape, Control Escape. I'll press Tab. I'm in relationship number 1. Now I want to type in x squared plus y squared equals 4. When I press Enter, I see the graph of a circle centered at 0, 0 with a radius of 2. To get rid of my circle, I'll press Control Escape. If I'm in relation mode and need to change back to function mode, I'll press Menu, select number 3, Graph Entry Edit, select number 1, Function. A shortcut to get to relation graphing and inequality graphing is to press the Delete button to get rid of your equal sign. Here you see all of your inequality graphing as well as number 6, relation. I'll select number 2, y is less than. Then I'll put in 2x minus 1. When I press Enter, I now see my graph of y is less than 2x minus 1. Don't worry about the line looking solid. As soon as I click anywhere in the graph, you will see that it truly is a dashed line. If I wanted to see a system of inequalities, I would go to Tab to open up my entry line, type in y. My inequalities are in my equals menu, so I'll press Control equals. I'll select greater than or equal to negative x. When I press Enter, I now see my system of inequalities. To clean up my screen, I'll simply start a new document. Home, 1, no. Number 2, add graphs. Let's go back to Menu, back to number 3, Graph Entry Edit, and this time let's look at number 3, Equation Templates. We have equation templates for line, parabola, circle, ellipse, hyperbola, and conics. If I hover line, I see that I have a template for line, slope, intercept, y equals mx plus b. Also, vertical line, x equals c, and a standard line, ax plus by equals c. I'll demonstrate with number 1, line, slope, intercept, and you can see you have a template, y equals, I'll put in 3x, tab, plus 1. When I press Enter, you see it in y equals 3x plus 1 form. I'll press Control Escape, go back to Menu, choose number 3, Graph Entry Edit, select number 3, Equation Templates, and this time let's look at number 2, Parabola. The parabola has Vertex Form, Standard Form, Vertex Form for x equals, and Standard Form for x equals. Let's choose number 2, Standard Form. And you can see your template is already there. 1, tab, -1, tab, -6. I'll press Enter, and now I see y equals x squared minus x minus 6. Let's go back to Menu, back to number 3, Graph Entry Edit, back to number 3, Equation Template, back to number 2, Parabola, and this time I'll select number 1, Vertex Form. I'll put 1 in the first space. I want it to have a vertex at +1, -2, so I'll put in 1, -2. When I press Enter, I now see y equals x minus 1 quantity squared minus 2. Let's go home. Select number 1, New. We will not be saving changes. Add number 2, Graphs. Go back to Menu. Number 3, Graph Entry Edit. Number 3, Equation Templates. You can go through each of these options. Number 3, Circle. Notice you have Center Form and Standard Form. I'll press Escape. Number 4, Ellipse. I'll press Escape. Number 5, Hyperbola. escape, number 6, conic. Escape, escape. Remember, once you change your graph from function mode, you can always change it back by going into number 3, graph entry edit, and changing it back to function, or you could create a new document. Let's now choose number 4, parametric. I see that I'm in parametric mode, x1 of t, y1 of t, and I see from 0 less than or equal to t less than or equal to 2 pi, and the t step is 0.13. For x1 of t, I'll put in 5. I'll press my trig button. I'll select sine, and I'll put in t. I'll press tab. For y1 of t, I'll put in 3. I'll hit my trig button. I'll select cosine. I'll put in t, and when I press enter, I now see my graph. I can also move my label, putting my cursor on top of the label, pressing Control-click to grab and move the label out of the way. Let's do one more just for good practice. I'm going to hover my label and double-click. That takes me right into x1 and y1 of t. I will use the clear feature to get rid of x1 and y1. Control-delete clears my entry. For x1 of t, I'll simply put in t. For y1 of t, I'll put in 1/4 t squared. Control-divide to get my fraction template. 1 in the numerator, 4 in the denominator, right arrow, and I'll put in t squared. I can arrow on down or tab on down to the last line. I'll make it from negative 2 pi to positive 2 pi. And I'll keep my t step at 0.13. I'll press enter. And now I can grab and move my label. And I can grab and move my graph paper so that I can see the entire graph. Let's go back to home. Select number 1, new. We will not be saving changes. Let's choose number 2, add graphs. Go back to menu. Number 3, graph entry edit. And this time select number 5, polar. We see that we are now in polar mode. I'm going to plot 5 sine 4 theta. 5, trig, select sine, 4, and then the theta symbol is in the pi menu, and I can arrow over and select theta. And when I press enter, I see our rows. I'll grab the label and move it off to the side. One of the nice things about the polar graphing is seeing it being plotted. If I go to menu and I choose number 5, trace, there is number 4, path plot. I'll select number 4, and this is a polar graph, number 3. And when I click play, I can see the animation of it being plotted. I'll press escape once. Again, I'll press escape to turn off the tool. Let's press tab to open up our entry line. And this time, let's put in 5, go back to trig. Let's select cosine 4. We'll go to the pi menu and select theta. We'll press enter. Move our label off to the side. And now let's go back to menu. back to number 5, trace, select number 4, path plot, and select polar. And when we press start animation, this looks very, very cool. Let's start fresh on a new graph screen. I'm going to press the Home button, select number 1, New, and say no to Do I Want to Save. I'll select number 2, Add Graphs, go back to Menu, this time number 3, Graph Entry Edit. Scatter plots are for data. I won't be covering that in this particular video. Let's look at number 7, Sequence. I'll select number 1 for sequence, and I'll put in an explicit formula. I'll go with 2n plus 4. I do not need to put in the initial term, as it'll substitute in for me when I go and press enter. I can now resize my window. I'll grab the axes and go towards the origin. And now I can see my sequence plotted. Let's try this again. Let's start fresh. Home, 1, No, Add Graphs, Menu, Graph Entry Edit, number 7, Sequence, number 1, Sequence. This time, I'm going to define my initial term. Let's make our initial term 3. I'll up arrow and I'll type in U sub 1, open parentheses. We want to have the term n minus 1 inside the parentheses, and then we will have plus 7. When we go and press enter, we see our initial term, and I'll grab the axes, and as I move, I can see my sequence plotted. Again, let's clear it all out. Home, 1, New, Document, no, we're not saving the changes. Number 2, Add Graphs. Let's now look at the table and trace features of the graphing application. Let's enter the function x squared plus x minus 2. Press enter, and we have our function plotted. If we want to see the table for this function, we can press Control followed by the letter T for table. This will split the screen, and you can now move in your table to see the coordinates that are plotted. If you wish to get rid of your table, you can press Control T again, and you go back to your full screen view. Another neat feature I want to show is that if you press Control Document to add a page, and you select number 1, Add Calculator, if I press the var button for variables, I see F1. I select F1, and I put in something like 0, and I press enter, and it evaluates F1 of x at 0. I'll do this again. Var, select F1, substitute in 1 for x, var, select F1, substitute in 2 for x. You can create your own table of values by evaluating the function at any given x value. Let's get back to our graph. press Control left arrow to go back to page 1.1. I now want to move into the Trace feature on the TI-Nspire. Go to Menu, select number 5, Trace. Instead of choosing number 1, Graph Trace, let's actually select number 3, Trace Step. I'll select number 3, and Automatic is the default. I'm going to overwrite the word Automatic by just pressing 1. I'll then press Tab and select OK, which means when I trace this function on 1.1, it will now go by 1 as my step size. I'll go back to Menu, back to number 5, Trace, and select number 1, Graph Trace. Notice in the upper left-hand corner, the Trace tool is active, and in the bottom right-hand corner, the current location is showing. I can now press the arrow right or left, and it will show me values plotted. If it comes across an important value, it will show it as the 0, as the y-intercept. Notice, I set the trace step size to 1. It would not allow the user to miss an important value. I can continue to arrow to the left, and it will also find other zeros. So a really nice feature is that I can plot these points along my graph. If I press Enter, -2, 0, the 0 is plotted. I'll right arrow my minimum. I'll press Enter to plot. My y-intercept I can plot. And my other 0 I can plot. I'll press Escape to turn off my Trace tool. I can grab and move this text so that it cleans up my graph. Let's start again to practice. Home, 1, No, add graphs. I'll put in x squared minus 5x minus 6. I'll press Enter to plot it. It goes off my graph screen. I'll grab my axes and go towards the origin for a zoom out. I'll move my label out of the way. To get rid of some of the dead space, I'll double click. I'll make this -8 tab. I'll make this 6 tab. I'll make this 8 tab. And I'll make this y minimum -16. Enter. So I now have a good representation of my graph. I'll press Menu, select number 5, Trace. Now last time I started with Trace Step and changed it from Automatic to 1. If I do not do that step and I simply select number 1, Graph Trace, I can arrow right or left, and the default appears to be going by tenths. It will still show all the key values, and you can press Enter at any time to plot any of the values you wish to see. It's working harder, not smarter, but students could find all the values that they need using the trace command. I now wish to get rid of these points that I've plotted along my graph. I'll press Escape to turn off my trace tool. I'll then press Control Escape to undo the points that I have plotted. Let's take a look at other trace menu items. Press Tab, and in f2 of x, let's enter in x minus 6 and then press enter. Let's go to Menu, select number 5, Trace, change Trace Step to 1, select OK, go back to Menu, back to Trace, and this time, since we have a system of equations, let's select number 2, Trace All. As I arrow right or left, I can see I'm tracing along the x-axis and seeing where those coordinates match up on each function. This is great to see the system. f1 and f2 both have 0, -6, and 6, 0. Let's press Escape to turn off this tool. Go back to Menu, select number 5, Trace, and this time let's select number 4, Path Plot. We have a function, so let's select number 1. When we press the Start Animation button, we can see both functions being plotted. Just another feature of the Trace menu. If you wanted to see that done again, the Reset Animation option is right here. However, I'm going to press Escape to deactivate the plot path and Escape again to turn off the tool. I wish to get rid of f2 of x. I'll press Tab, hit the up arrow once so that I'm in f2 of x, and I will simply delete out my function and press Enter. Let's now focus our attention on Analyze Graph. Let's go to Menu, select number 6, Analyze Graph, and select number 1, 0. In the upper left-hand corner, I see the tool for finding zeros. In the bottom left-hand corner, it says Lower Bound. As you swipe your finger on your cursor, a vertical line is attached to your cursor. You can press click or enter once, and your prompt in the bottom left changes to upper bound. As you move your cursor, if a 0 exists, it will find it. It will only, however, find 1 0 at a time. It will not find both if they're in the shaded region. So you'll press click or enter, and it will find your first 0. Rinse and repeat to find the other 0. Menu, number 6, Analyze Graph, number 1, 0, and this time press click or enter once, swipe your finger on your touchpad, click or enter a second time, and you have found both zeros for this function. Now let's go back to Menu, back to number 6, Analyze Graph. As we have a minimum point on this quadratic function, let's select number 2, Minimum. Again, in the upper left-hand corner, you'll see the minimum icon, and it says Lower Bound in the bottom left. I'll click once to drop the lower bound, and as I swipe to the right, it will find my minimum for this function. I'll press enter or click again, and it has found and plotted my minimum. I'll grab my coordinate and move it out of the way, for I'm now going to go to Menu, select number 6, Analyze Graph, and I'm going to jump down to number 8, Analyze Conics. And number 4 on this menu says Axis of Symmetry. I'll select number 4. I see the icon in the upper left-hand corner. I can simply hover the function anywhere along it. And if I click it will find my axis of symmetry and label it. Press Escape to turn off the tool. Press Control Escape to hide our axis of symmetry. We need a second function in order to practice with the intersection tool. We'll press Tab to open up our entry line. In f2 of x, I'll simply put in -6. When I press Enter, I see f2 of x plotted. I'll go to Menu, I'll select number 6, Analyze Graph, and I'll select number 4, Intersection. The intersection tool is in the upper left-hand corner. Again, I have the vertical line, and it's prompting me for lower bound. I'll press Enter or click once, and as I move my cursor, it finds the point of intersection. Again, it will not find both points of intersection at once. I can press Enter or click, and that will find my point of intersection. Menu, Analyze Graph, Intersection. Repeat the process for the second point of intersection. I'm going to grab the labels for my coordinates and move them out of the way. I want to now explore the bounded area feature in my Analyze Graph menu. I'll go to Menu, select number 6, Analyze Graph, and the bounded area option is number 7. I see the bounded area icon in the upper left-hand corner, again the vertical line, and it says lower bound. However, when I move my cursor, I get the option of doing the point on tool. So I can find this point of intersection, 0, -6, and as I move my cursor, I see the bounded region being shaded in, and it's finding the area. I can go to the other point of intersection, click, and I have found that area for the bounded region. Since we have a lot going on our screen, I think it's best, before we move on any further, to clean it up. I'll go Home, select number 1, New. I'm not going to save the document, and I'll select number 2, Add Graphs. My function will be x squared, and I'll press Enter. I wish to move my label, so I'll put my cursor on top of the label. I'll press Control followed by the center click button, and I'm going to move it out of the way. I now am going to Menu, and I'm going to make a pit stop at number 8, Geometry. I want to select number 1, Points and Lines. I'll select number 2, Point On. I now see my Point On tool. I'm going to hover someplace along the function, click on it, and then click once more to leave a point on the function. I'll press Escape to turn off the tool. Now that I have this point plotted on my function, I can double click on the x coordinate and I can make it any x value I wish. I'm going to make it 1. When I press Enter, it now moves to 1, 1. I'm going to go back to Menu. I'm going to go back to number 8, Geometry. This time I'll select again number 1, Points and Lines, and I'm going to select number 8, Tangent. I see my Tangent tool in the upper left-hand corner. I'm going to select the point that I put on this function. I'll press Escape to turn off the tool. I'll grab and move my text and my coordinate. I see the tangent to f1 of x equals x squared at 1, 1. The equation of that tangent is y equals 2x minus 1. I can grab and move that point along my function. And in real time, I will see the equation and the point change. I'm going to change it back to my coordinate 1, 1. I do this so that I can now show the derivative tool. I'm going to grab my equation of my tangent line and move it out of the way. I'm going to grab my coordinate for the point on out of the way. Now we go back to menu, select number 6, Analyze Graph, select number 5, dy dx. The icon is in the upper left-hand corner. It's asking where do we want to position it. I'm going to select our point on, and now I can grab the point on and notice the dy dx, the derivative at a given x value for my tangent. Great for building the fundamentals of calculus. Let's start a brand new graph screen. This time I'll press Control Dock, select number 2, Add Graphs. f1 of x is already defined on 1.1. On 1.2, I'll start with f2 of x being negative x squared plus 4. I'll press Enter, and I'll see my function plotted. This time I'm going to use my integral tool. I'll press Menu, select number 6, Analyze Graph, select number 6, Integral. Again, upper left-hand corner shows the icon, lower bound in the bottom left. I'm going to select the intersection point with the x-axis, and as I move my cursor, I'm starting to see the area trapped under the curve. I'll select the other intersection point, and I have found the area under the curve. I'm going to press Control Escape to undo the area under the curve. Let's now focus our attention on the geometry menu. We'll go to Menu, select number 8, Geometry, and select number 1, Points and Lines. I wish to choose number 2, Point On. I see the Point On tool in the upper left-hand corner, and I'm going to hover my function at some point along it. I'll press Enter once, and I can position where I'd like this first coordinate to be plotted. I'll press Enter again, and that point is now on my function. I'll press Escape to turn off the tool. I'm going to move my cursor on top of my point on. It says point on. I'll press Control-click to grab the point, and as I move using my touchpad, every time I come to an interesting or an important value, it will tell me that value. This is a one-stop shop to finding all of the key values along a graph, instead of having to go back to Analyze Graph each time. Let's go back to Menu, back to number 8, Geometry, select number 1, Points and Lines. I want to point out this feature, Points by Coordinates, and the shortcut is just pressing the letter P. So if I select Points by Coordinates, I can now type in coordinates. 3, enter, 4, enter, and it will plot that coordinate on the screen. This could be very nice for students trying to determine if a coordinate lies on a relation or a function. I'm going to go back to Menu, back to number 8, Geometry, and this time let's select number 2, Shapes. If I selected number 2, Triangle, I see the Triangle tool in the upper left-hand corner, and I have the ability to drop 3 points. Click once to drop the first point, click a second time to drop the second point, and a third time to drop the third coordinate. The icon in the upper left-hand corner means that the tool is still on. I'll press Escape to turn off the tool. I can grab my label and move it out of the way. I could now go back to Menu, select number 1, Actions, and number 8 says Coordinates and Equations. I could find the coordinates for these three vertices of my triangle. For more on geometry, please watch my geometry application video. Let's add a new graphs page. Control Doc, add graphs. I'm now on 1.3. Piecewise functions. Let's go ahead and add another graphs page. Control Doc to add page. Number 2, add graphs. Let's make f3 of x a piecewise function. The piecewise template is located in the templates key, the button directly to the right of the 9. I see my piecewise template, and now I can enter in the function. So the function will be x squared. I'll press tab to go to my domain. I'm going to put in -1, control equals. I'm going to select the less than or equal to. I'll put in x, control equals, less than or equal to, +1. I'll press tab. I'm going to make my second part of this piecewise function be -x, tab, and I will make it for all values of x greater than 1. I'll press enter. I'll move my label, and I now see my piecewise function. By the end of this video, I hope that you feel much more comfortable with the graphing application on the TI-Nspire technology. Again, my name is Dana Morse. You can email me questions at dmorse@ti.com, and I encourage you to go to TI's website for many free resources, www.education.ti.com.